All right, our last objective for the unit is that you write equations of lines using properties of parallel and perpendicular slopes. So just a quick reminder, parallel slopes are the same as each other. They're numerically equal. Perpendicular slopes are opposite reciprocal. And this is going to be kind of the easy part. You're not going to forget this. A lot of this is going to be just the mechanics of writing lines in slope-intercept form. So the example that we have here, I've got a line and a point that it goes through, and they're asking us to write the equation of two different lines, one that's parallel and one that's perpendicular to the given line, but that goes through this point. So the first thing we need to know is the slope of this line. Sometimes you'll be given a line that's in slope-intercept form, but this one is not. It's in standard form, so we need to get y by itself. Start by subtracting 2x. That gives us negative y is equal to negative 2x plus 8. Then we'll divide both sides by negative 1, which gives us y is equal to positive 2x minus 8. The only thing that matters about this for what they ask for is the slope. So our slope is 2. The y-intercept of negative 8 is never going to be used for what they're asking for. So the first thing they asked for in part A was the equation of a line that is parallel to this line. That means it has the same slope of 2, but that goes through this point. Now there are a couple different ways that you could do this. I'm going to use point slope form because that's something you use more often later in math, especially in AP calculus. So point slope form is y minus the y value is equal to the slope times x minus the x value. Again, this is one of the ways to do this. So in this case, the point that we have is 14, negative 12, and the slope that we have is 2. So I'm going to write y minus the y value, so that's y minus negative 12. You notice I just turned it directly into y plus 12, is equal to the slope, which is 2, times x minus the x value, so that's x minus 14. And in order to get into slope-intercept form, we need to get y by itself. So there's basically two steps we're going to do here. First is I'm going to distribute that 2, which gives me y plus 12 is equal to 2x minus 28. And then the second step is going to be to subtract 12 to get y by itself. Now I'm just going to write my answer down there. This gives me y is equal to 2x minus 40. And that's going to be our answer. We can, of course, check this because it is indeed parallel to this initial line because it's got the same slope. And if you plug in 14 as an x value, you will get negative 12 as a y value, which means it does go through that given point. We're essentially going to repeat this process right now as we do the perpendicular slope, except that the slope is going to be different. So if the slope of the original line is 2, a slope that is perpendicular to that is going to be the opposite reciprocal, so that's negative 1/2. But it still says it goes through that point, so we're still going to be using 14 and negative 12 when we set this up. So it is going to be y minus the y value, so that's still y plus 12 minus negative 12, is equal to the slope, negative 1/2, times x minus the x value, so that's x minus 14. I'm still going to start by distributing that negative 1/2, which gives me y plus 12 is equal to negative 1/2 x plus 7. I did negative 14 times negative 1/2. And our last step to get y by itself is to subtract 12. When we do that, we're going to get y is equal to negative 1/2 x, and then 7 minus 12 is negative 5. Again, we know that this is perpendicular to the original line because it has an opposite reciprocal slope. And if you plug in 14 as your x value, you will get negative 12 as your y value, which means it does go through that point. So our objective today was that we write the equation of lines, which is all the right side of this, using the properties of parallel and perpendicular slopes, which is the left side.